Here is my solution video for problem 13.3 as stated in the lecture PowerPoints. It asks us to consider two bars made of two different materials. These bars are tested in a uniaxial tension test. F1 and F2 are the magnitudes of the tensile forces applied on the bars. E1 and E2 are the elastic moduli, and A1 and A2 are the cross-sectional areas perpendicular to the applied forces. It asks us, given the conditions below, to determine the relationship between the stress on material 1 and the stress on material 2, and then the strain on material 1 and the strain on material 2. So I have written down here exactly what the problem asks us, defining F, E, and A, and asking what it is being asked, which is to determine the relationship of stress and strain between the two materials. So for the first material, or for the first condition, we have stress is equal to force over area. So I've written this out for material 1 and material 2. Given in the problem, A1 is greater than A2 and F1 is equal to F2. So assuming that F1 is equal to A2 and A1 is greater than A2, we can assume that F1 is equal to F2 is equal to 1 as just a filler number. And then A1 is equal to 2 and A2 is equal to 1 because A1 is larger than A2. And these are filler numbers just to demonstrate the relationship. So the stress on 1 is going to be 1 over 2, and the stress on 2 is going to be 1 over 1 because A is on the bottom and it's A1 is greater than A2. That means that this fraction is going to be divided, or this force is going to be divided by a larger number than this one, which means that the stress on bar 1 is less than the stress on bar 2. For the strain, we have strain is equal to stress over elastic modulus. And I've written this out for bar 1 and 2. So we can assume that strain 1 is equal to 1 over 2 times elastic modulus 1. And I got this from before our stresses being 1/2 and 1. So over here, strain 2 is equal to 1 over 1 times E2. So assuming that E1 is equal to E2, we can assume that they are 1. So that means that the strain of bar 1 would be 1/2, whereas the strain of bar 2 would be 1. So E1 would be less than E2. It's using the same relationship as before. Now, if we assume that E1 is greater than E2, because they have not defined it in the problem, then the same applies. Strain 1 is less than strain 2 because it's on the bottom. It's going to be multiplied higher on the bottom, or it's going to be divided by more, so it's going to be a lower number for E1. E2 we ignore because, or well, we don't ignore, but is not the same because it is greater than, it is less than E1. Sorry. Now, if we assume that E1 is less than E2, then we cannot conclude an answer. So this is because even though we have the 2 over here multiplied by the E1, so basically whatever the result of the stress is, E2 could be greater than that multiplicative. So it could be greater, it could be less than, it could be equal to, we don't know, because we're modifying both denominators in these equations. So that is why this we cannot draw a conclusion from. For the second problem, it asks E1 is greater than E2, and then the forces and areas are the same. So what's the relationship between stress and strain of these two materials? So I wrote out the same equation, stress is equal to force over area for both materials. So if F1 is equal to F2 and A1 is equal to A2, then these are going to be the exact same value. So stress 1 is equal to stress 2. Now, if we have strain is equal to stress over E1, or over E, and have that for both materials, and we're given that E1 is greater than E2, then let's assume that E1 is equal to 2 and E2 is equal to 1, just like we did up here. That means that the strain is equal to stress over 2 for E1, or for number 1, the material 1, and the material 2, stress is over 1, because this is being divided by a larger number. And since stress is equal between these two, then this strain 1 is going to be divided by a larger number than strain 2. So that means that strain 1 is going to be less than strain 2.